Hi everyone, this is Jesse here from SkyCiv. Today I just wanted to do a quick video talking about the quick design bulk group capacity calculator for the AISC 36016 and how we can use it to solve a reward example. So what I want to do is I'm just going to open the tool. First of all, I'm going to scroll down to the quick design in the design software section. Go to the OS 10s tab and click on the bulk group capacity calculator. Now the example that I'm going to be looking at today is just taken from this companion to the AISC steel construction manual, version 15.1. And inside this document, there's just a bunch of examples. The example I'm going to be looking at is example J.3, which is combined tension and shear in bearing type connections. So what we can do is we can just go into this calculator. If you haven't seen this calculator before, we have two different other versions of this same software, which is one for the Australian version and one for the European version. But today we're just going to be looking at the American version. So what we can do is we can input the values in to be the same as for this design example. And this design example, we're just checking for a single bolt. So we don't need to worry too much about the geometry here or the plate geometry because we're looking at the forces on the bolt. We're not looking at the forces on the plate or bearing tear out. So these dimensions aren't going to matter. Just ignore those. The bolt size in this example is 3/4 of an inch. The bolt grade is considered as group A. And we have a thread condition N and a bearing type bolt. The plate properties aren't going to matter because we're not looking at the strength of the plate. We can just leave it as a standard hole, but that's also not going to change any of the calculations, again, because we're not looking at bearing or tear out. For the analysis, we can choose either method of design. We'll just keep it as ASD method. These methods aren't going to matter. These are more about distributing the forces on the bolt, particularly when we have moments by. In this case, we're just going to put the tension and shear force directly onto the bolt. So we can ignore that. We can ignore these inputs. For prying, I'm just going to put the factor of 1, which means that we're just not going to consider prying. And for our design loads, I can just put them in the same as what the example calculates. So set this all to 0. Now we're given a tension load. The tension we can put in as this FZ value. This will get converted directly into a tension force. So for FZ, our tension force is going to be 15.5 kips. And our shear force, we can either put it in as Fx or Fy. Both of those will get converted directly to a shear force. So I'll just put it in as Fy as 5.33 kips. And that's all the values we needed. So I'm just going to press run. And we'll have a look at the values that get calculated. So we get this nice report in the middle. We have our input summary, calculate geometric properties. But what we really care for this example is we care about the bolt strength calculations. So what I'm going to do is I'm just going to click on PDF report just so I can zoom in to make this a bit bigger. And this is typically what you'd want to save if you're doing a design and perhaps you want to share this with another engineer or client. This is probably what I'd click and save because it just gives you that nice report that you can share with others. So I'm just going to scroll down again to our bolt strength calculations here. So here we see a nice summary at the top of the values like our cross-sectional area for our bolt, diameter. You see where some of these values come from with these tables. And then we can look at the shear capacity. So first of all, we calculate the shear stress of the bolt. This is the same as what they calculated in their example. And actually we can get this from table J3.2 in the AIS specification. Then we can calculate the nominal shear strength and the shear utilization. So it's a very linear kind of approach in calculation. It's very simple and straightforward. And we get this utilization 45%, same as what they calculated in the design example. Very similar calculation with tension capacity. We get this tension stress value, which we could get from table J3.2 of the AISC 36016. We can then calculate the nominal tension strength based on the area of the bolt and calculate the tension utilization of the bolt as 78%. Same value that they get in their example calculations. Then we get down to the combined tension and shear calculation. So here, the way this standard does it is we get an effective tension stress or strength. So instead of having this tension stress here of FNT, we have an effective one, F-NT. And in this example, in this calculation here, what happens is we have 1.3 times FNT minus FNT times, and these values here just end up being the exact same as this calculation here, this UIB value. So basically, we're just reducing based on our shear utilization. And the higher the shear utilization is, the higher this reduction is going to be. And of course, we have, if, for example, this was 0, this would be 1.3 times FNT, which would give us a higher value than what we'd get in our regular tension shape. So that's why this is limited by FNT. It would make sense for it to get stronger. So we've got this limitation here. And what we see in this calculation is we end up getting an effective tension stress of 76.78 KSI. And the design example calculates 76.7, so differences generally just from minor rounding in the calculations. And then we can just use this stress to do a very similar calculation to what we did up here. Instead of using F and T, down here we're just going to use F-NT, and when we check our utilization, we're just going to use that tension force and compare it to that tension strength. And so we can see this down here, we've got our effective strength, FNBT times AB, is going to give us a strength of 33.92 kip, and that gives us a utilization of 91%. So we'd expect this utilization to always be higher than this tension utilization here, which is 78%, just by the nature of this calculation. So that's an example of doing combined tension and shear check, very simple one. If you have any questions, feel free to leave a message here. Otherwise, I just recommend having a play around with the tool, with the calculator, maybe run through some examples of your own from that textbook. And let me know if you want me to run through any of these examples in the calculator. I can make another video. Or if you have any problems with the tool, let me know and I'll be happy to help. Something else I'd like to point out as well is the more complicated examples. On the platform, we do have the connection designer. And the connection designer is going to allow you to make much more complicated sections. So just having a quick look through here. We can see we're going to be able to create much more complicated sections. And we can see that with something like this. So this is a very simple case, but there's a bunch of different calculations we can do with Connection Designer. The Quick Designer allows us to do something quick and easy, just like we did in this example. Thanks for watching the video. Goodbye.